Okay, our next section, 7.2, is properties of powers. You can see we will be able to take any power, and when we're assuming the base is positive, talk about it and evaluate anything that has a positive exponent on it as well. Simplify expressions using these properties, recognize the properties of these different powers, and solve some real-world problems that contain these. So let's start and look at a couple of the properties. So knowing that, here is your first one. If we multiply powers with the same base, okay, so powers multiplied together, like bases. For any non-zero number a and any integer m and n, we would have the product of power rule. So notice, you have to have like bases, and if the bases are alike, a and a, we will just add the exponent as a shortcut. So an example here, if we had 3 to the 5th times 3 to the 4th, you know you used to be able to do 1, 2, 3, 4, 5 times 1, 2, 3, 4. But after you saw that enough times, you could realize that you were really just multiplying 9 3's and write it shorter as 3 to the 9th power. You also know you can use your calculator, but we're not into that right now. We're not worried about what is the value of 3 to the 9th. We're worried about, do you understand how you get these shortcuts? So here's some examples of different combinations, and it says simplify each expression. So if you look here, using our properties, we should be able to look here and look for like bases. I see a C and a C, so like bases, alphabetical order, C to the 6th times D to the 3rd. And you really don't even need the dot for multiplication here. On part B, though, we've thrown in some numbers as well. So you always want to multiply your numbers as normal. So I'm going to go 5 times 2 times 3. 5 times 2 is 10. 10 times 3 is 30. We'll get our 30. Then we look for like bases. I see an x to the 1st and an x to the 8th. So that has to be like bases. Add the exponents, x to the 9th. With a y to the 4th, nothing to be multiplied. So 30, x to the 9th, y to the 4th. Like bases, add the exponent. Product of powers. So let's go to, what if we say a power of a power? What does it look like? For any non-zero number a and an integer m and n, then that means, look, we only have one base with a power, that whole thing taken to another power, hence power of a power. So we have a power, it's taken to a power. The rule is multiply them. What that means, let's go back to typical, and even let's go back to what if I had 2 to the 3rd and that taken to the 2nd. You knew that that meant 2 to the 3rd times 2 to the 3rd. And that was like bases, add the exponents. So it really meant you had 6 of them. Well, 6 of them is quicker if you just multiply the two powers. So with that, and we simplify, we need to take that expression and take c to the 4th, c squared, c to the 4th, and c squared. Let's close iPhoto that's opening here. All right, c to the 4th taken to the 2nd would be c to the 8th, and then we still have our d to the 3rd. Down here, power of a power. We see a problem right here, so we're going to keep the 5. We have x to the 2nd taken to the 2nd. That would be x to the 4th. And then we still have the 2y to the 4th, and we still have the 3x to the 8th. So once we did the power of power, we can go back and do our like rule, like bases. But again, remember all our numbers first. 5 times 2 is 10, times 3 is 30. So we get 30 for our numbers. Then we're looking for x to the 4th and x to the 8th as our like bases. Add the exponents, so that'd be x to the 12th with our y to the 4th with nothing like it off to the side. So 30, x to the 12th, y to the 4th is our final answer. The only examples of using power of a power were here and here. Otherwise, we went back and used power of products. Next one, multiplying powers of a product. If we have a product, two things multiplied together, taken to a power, the rule is you could take each one separately if that helps. So here's an example of 3x taken to the 4th power would be 3 to the 4th, x to the 4th. And 3 to the 4th is better known as 81 when we multiply it out. and 81x to the fourth would be the final answer. So on these, we get right here an example of power of a product. Here's another example of power of a product. Those would get done first. So 2 has to be squared, that's 4. C has to be squared, that's c squared. We still have to multiply times d, so alphabetical order, c squared, d cubed. 5 has to be squared, 25. X has to be squared, x squared. We still have got our 2y to the fourth and our 3x to the eighth. Again, we need to multiply. Numbers first, 25 times 2 is 50. 50 times 3 is 150. Look at your x's next. We have an x to the second and an x to the eighth. Like bases, add the exponents. So that'd be x to the 10th. And we still have our y to the fourth with no like term. So you can see how we're using them. And we always apply that bigger property first to our work. Now, the last combination I think that we're going to work with is division, and this is what happens if I have like bases in division. So I think we're going to get two properties where we also have to do division in. This first one happens to be quotient of powers. So if you have like bases, I got a b and a b with like bases. An example would be like x to the fourth, and the reason this works, think about it, if I had 4 x's on top multiplied together and 2 x's on the bottom, and we go back to our canceling property, that means one of these with one of these, one of them on top with one of them down below, and we're going to get just 2 of those x's remaining, and that's why our final answer is x squared. We don't want to have to do that expanded form every time. We want to see the pattern, and we're seeing the pattern saying, hey, 2 will cancel into the 4, it will go in there and leave us just 2. So if we follow that rule and we come down here and try it, here's our division. 8 divided by 2 is normal division. 8 divided by 2 is 4. And now this is where we go. Hey, I have 8 c's on top, 3 on the bottom. 8 take away 3 would give me 5 c's up on top. Next one, we'd have to do this division first before we did our multiplication. So let's do that. We would have 35 divided by 5, 7. X to the 12th divided by x to the 7th, so like bases are subtract, that would give us an x to the 5th, and then times 2y to the 4th. So final answer, numbers times numbers, 14, x to the 5th, y to the 4th. And our last quotient rule is what happens if I have a quantity. So what if I have a division problem to begin with and it's just raised to a power? We're saying if it's easier, you can raise each part separately and do the math. So here's the example. If 3 is divided by x, and it's to the 4th power, you could then take 3 to the 4th, x to the 4th, do those separately, get 81 over x to the 4th, and have your fractional or rational answer. So down here, again, you can see them. Here are the division problems that need to be attended to first. So if we have to square everything in the inside, here we go. 4c squared over 25. That'll still have to be multiplied by d cubed. Let's just elongate that. Since d cubed is not like anything, we're going to end up with 4c squared d cubed all over 25. On this next one, I think we'll have a little more work. Let's square everything on top in our parentheses. So 25x squared times 4y squared, then times 2y to the 4th. If you want to think of it over 1, you can. And times 3x to the 8th all over 1, you can. All right, here we go. We have a multiplication rule, and actually we have some canceling we can do, so maybe let's do that first. We've got a 2 goes into 2 once, 2 goes into 4 twice. So now my numbers are a little smaller. 25 times 1 times 3 up on top is 75, all over 2 on the bottom. Then you look at your numerators. I see an x to the 2nd and an x to the 8th. So like bases, add the exponent will give us x to the 10th. Lastly, we see this division look right here with the y squared and y to the 4th. The rule is subtract the exponent, so I think that's going to leave us a y to the 2nd up on top. So final answer, 75, x to the 2nd, y, or x to the 10th, y to the 2nd, all divided by 2. So we threw 5 rules at you. You can go back and look at those 5 as I do. Put them in your notes. 2 different division rules and 3 different powering or multiplication related rules. Know them well, know them what order, when do I multiply, when do I add exponents, when do I, if I divide, what do I do? Because that's all what today's lesson is about. So look at those, know those, get used to them. We will practice them. If you have any questions, bring those questions with you to class.